Hey everyone, we're going to get started here. Sorry for the late start today. Welcome to another Common Lisp study group. I'm your host, Ram Badam with Atlanta Functional Programming. Before we begin, a couple of announcements. Atlanta Functional Programming is going to be announcing a few talks in the coming weeks. Please stay tuned to our meetup page for upcoming updates. And I'm hoping that our high talk is being well underway, but that's one that's going to be down the pipes. I'm also going to be starting a series on functional programming with C++ in the coming weeks. Stay tuned about that for further announcements. And for folks who are interested in giving a talk, we have now our virtual platform set up so that we can schedule talks for folks. Just let us know your idea, and we'll put it into the schedule accordingly. Today, on the Common Lisp Study Group, we're going to be talking about something that I actually found recently in a Twitter feed. I will give you the handle of this individual. There's a very nice Twitter user who posts Common Lisp projects that should be highlighted. And one of them caught my eye that I thought was particularly interesting, which is a library that would generate tech documents in Common Lisp. And being a LaTeX user, being able to write that stuff in Common Lisp would be pretty awesome. So today we're going to be going through that. I haven't actually had a chance to go through this particular library in detail. I just breezed through the documentation, and I thought this would be a nice library to experiment with live and see how difficult or limitations it is, and go through it with you all. So without further ado, let's get started. The library is called texp, like texp, like S expressions, but it's with a T instead of an S if you're looking for it on Google or any other search engine. So I'm going to go ahead and fire up Sly here. And start up. This library is available on QuickLisp, and if you look it up, the documentation is on QuickRef as well. I'm going to first load up Quick Project here and just, sorry, not Quick Project, CL Project, so that we can actually start, creating a little project on this. What's particularly interesting about tech and in general as a markup language, as hopefully most of you know, but if not, this might be news to you, is that it's been around for over 30 years. The markup language was actually one that Donald Knuth, who's also the author of many, great books on computer programming, particularly most famous for The Art of Computer Programming, actually took a hiatus from writing The Art of Computer Programming to design this system. It's particularly interesting because he thought it would be a fairly simple project, but when he started going through and understanding digital typography, the design of tech and its font designer, Metafont, ended up taking a decade. So the time between Volume 2 of Art of Computer Programming for Volume 3, that decade was due to the fact that he was designing this entire typesetting system with the primary purpose of actually preserving his documents, because it was becoming very, very hard to switch between word processors when the old word processor, would get, either obsolete or the company goes out of business, and the format that he was using to write his books was in a format that was difficult to import into another system, which ended up obviously inspiring him to create this one. So we're going to go ahead and create our project here. Standard, full name texp demo. I'll go ahead and post this guy in the Atlanta Functional Programming GitHub page, and I'll post a link for folks who are watching on the YouTube video itself, so that you don't have to go hunt it down. We're going to go ahead and use our standard. We're going to use Alexandria. I may not use Serapium, but I may add that later, and then we're just going to, of course, add texp. Now, go ahead and see if we can load this. Texp demo, and there we go. So let's go here, and let's open up the files. All right. So, to give a brief overview of a tech document, actually, hold on. I just realized I'm not sharing my screen with fellow people on the chat. Just 1 second. There we go. Hide this guy. And just make sure there aren't any questions. Cool. Okay. So let's see here. So for folks who aren't familiar with tech, let me give you kind of a little bit of a breakdown of a tech document. Tech documents have many different types. So they start with a preamble, which consists of you specifying what type of document you're creating, known as a document class. You also specify in that document class, the size of the font, maybe even the font type. You would specify then whether or not you are writing an article or a scientific paper. A lot of and then you would normally add a bunch of packages that are written that are tech macros and additional functions that were written specifically to format the text in a specific way. And tech has a boatload of different packages, like packages from designing state machines to whole packages of functions that allows you to use tech as a spreadsheet. It's a particularly fully versatile programming language for specifically typesetting documents. And Metafont, it's complementary package and library, which we are not going to be discussing here, because I don't believe that there's a common Lisp library that gives you the ability to use Metafont right now. That library ends up allowing you to further refine the font systems and create your own fonts for the purposes of getting better typesetting inside your documents as well. So what texp provides us is a bunch of, like, a couple of exported definitions. One is a macro called deftech, and two, a macro called tech, and then of course escape. So one way of writing this a basic document, if I understand what their deftech example is doing, let's see. Let me try and read this. Right. So we're going to first talk about tech, which is a macro that allows you to define some basic documents. Make sure I got this right, and then we'll go work our way up to def tech. Components, test expressions, syntax, standard output. Just make sure my give me just 1 second here, because there is a difference between. There's one thing that I want to mention to folks watching this. There is a difference between tech and LaTeX, and LaTeX provides a couple of nice macros that converts the appropriate tech thing. So trying to make sure that I give you pure tech, and texp is just pure tech. It's not LaTeX. This gives you more flexibility because that's you're going into the macro level of the system, but the cost of that, as with anything, is of course you're going to be dealing with writing more macros that LaTeX has already provided. So one thing about this library that I'm not entirely happy about is it's just pure tech, but since I've done pure tech in the past, it's just I have to go and remind myself what the difference is. Because LaTeX does the document class, but it was in that's what I was looking for. It's been a while since I looked at this. Yes. And for folks who are interested, there is a free book on this topic called Tech by Topic that you can use to actually go read through this. I'll post a link of it. It's available for download from CTAN, which is the tech kind of like CPAN, the tech package manager. All right. So let's try some basic def tech first, and then go down into the tech to write a full document, shall we? Now, what this is going to do is this is going to dump tech straight into your standard out. But since I'm writing this here, it'll be particularly interesting. So is a macro that I have not seen in the documentation. So let's try a basic macro def-tech. This guy is going to be a macro that allows you to specify a name that takes in an argument. And what you can do here is just dump this argument. So like if we're writing a function that just says hello, and you grab the name of this function, you can do texp, grab the parameter, and then it will just go ahead and do that. So if we go and compile this, you see that on the standard out, which I just realized on the stream, it's going to be a bit small. You can see here on the command line, what we've done here is using def-tech, we've essentially created a macro, which in tech is created by doing /def. The label of it is the same as our function, and then we can just go ahead and dump the format string that we're going to end up doing inside this document here. That #1 here, that's before the brace, is saying that this function is taking a single parameter, and then it's using it in the format of this particular thing. And you could do some pretty interesting things once you could start using more like tech. So I'm not sure if I could do this, but let's see if this works. Text BF, and if I do this, let's see what that does. No, so this has to be that. 15. Yes, okay. So escape characters looks like if you're doing standard format strings here, /t, /r, and /n are special characters. So you're going to have to put a double backslash in order to get what you need in the formatted string. But what textbf just did is this macro that we just created essentially is returning a bolded string that says hello, whatever the person is. So BF stands for boldface. Other things that you could probably do is if you're writing some things and you want stuff in Courier, you could do TT, which is type, which will give you like Courier-like fonts, monospace fonts. IT is for italicize and so forth. So this allows you to end up writing a particular set of functions in a formatted way in tech, and then you could just call that function inside of your document. Tech itself has 4 processors. It has an input processor that takes whatever stuff that's coming in as a file system and then tokenizes them, and then it goes through an expansion phase where if it finds during the tokenization phase, macros, conditionals, and stuff, just like what we're doing in compilation, it'll then expand them to the appropriate tech sequences. The third phase is, of course, when it finds control sequences inside of the tech, and then executes them in order for us to generate more documented, tech code. And then finally, the rendering phase or the visual processor is run, which then takes your final document and then goes through and generates what's called the DVI output, and that's a file format that's used actually that's a fully typeset document. So original tech was written with the output being DVI. So folks coming from the LaTeX world that are watching this, LaTeX added to this and added some additional functionality, one of which was a entirely different processor that converted tech into PDF, and that's what PDF LaTeX is. There's also a PS LaTeX, so if you want to generate PostScript files, you could certainly do so as well. I'm not entirely sure, and this is something that I need to go in and dig in a little deeper on this. Like I said, this is my first live coding on this library, so please bear with me. There is given that it is, dumping out this stuff to the standard out, if we write it to, like, say, an input stream, we could certainly do so. I'm wondering if the generated text can then be passed into LaTeX to actually generate like a PDF or a PS file. That's something I'm going to have to deal with. I'm probably in a subsequent episode giving you some updates on that. Just make sure. What's particularly useful about this is you could then see a way of writing code so that you can generate the document as just part of part of the normal development life cycle, and then you could just at a top level not only write your common list system, but you could also have a fully formatted piece of documentation, which is useful in many cases. Let's do this here. So let me see what happens when I do texp. Let's see what happens when I write this. This is document class op pt article. This is a very simple document that I'm basically writing right now, and I may not be giving you the full experience here, so bear with me. I will, since this is not using, even though this is defined as hello, this is not using anything particularly, it's not going to be generated into our final text document. So I have to figure out how to hook those two macros together. Hello world, let's see if this, so all this is generating a dumb document that, let's see, not space CM, space MCF. There you go. Okay, let's see something here. Okay, I see what I have to do here. Okay, so let's go ahead and actually write out what this would kind of look like in in using this library in pure Lisp. So what I just did is, you could certainly use this library to write code like this. Obviously, this is kind of not really leveraging what it is. Let's write a few functions here, and then like do this. Let's do hello, and let's see what happens. If we call this, very nice. This actually did what I expected it to. Although I would prefer a new line. This is not going to happen, is it? Let me clear up. Clear. Let's try this again. Nice. So that actually does work. Okay. So begin document. Called hello world, but it didn't actually call our function. So let me see if, oh, okay, I see. I have to put this around, something here that doesn't look right. What is it? One second. Forgetting my p tech. We have to do this. Do this. So anytime you want a new line, you have to put a break. So I'm going to go ahead and do this way. That way it's kind of nice for us to actually look at this document. Nice. Alright. So, what did I miss here? This def tech should actually have created calling the macro is the interesting one. I need to say, okay, so let me just make this all into a single function. Define hello document. And then you can specify the name that you're going to want to generate. Put that here, and of course we need to go and format everything. So we have indentation. Then I think I have to do not that. I'm going to do this. Let's see what this does. Let's see here. This guy is okay. Let's see this. Let me see if I can do this. This will not work because of the fact that it's not getting. No, that is correct. Never mind. I'm being dumb. I keep forgetting that this is how LaTeX works. So what I was trying to do is trying to see why this this document wasn't actually getting the item that we just generated, the macro. But I forgot that in tech, in order to execute a macro, you have to use backslash. So it was doing the right thing before. Name is so. We don't even need this right now. We're going to be doing something more fancy later. Okay, so let's go through this here. So, so what tech does is it starts any thing, like I said, with the preamble. This here. I'm not entirely sure. I know this is required in LaTeX. I think in tech, this document class and begin document, end document is not necessary. I think you just need to start with plain tech. So we could just take this guy out and this guy out for the time being. And then it becomes this, which shift. Actually, do this. And so this is a basic tech document. What this does is we start the tech document saying, hey, hello name, and then actually I need to specify something here. Say that. So let's say that we do hello world, and when we generate this code, what this will do is it will call if def was defined. If this was defined in the same area, it will go ahead and generate that code so that the item will be created and will call out this function that we defined here, and then obviously render hello world in boldface. So let me see what if I can actually go in and correct here so that we can get both of them in the same function. So we get the definition and the definition of hello and our stuff in a single function. So that's what I was trying to do earlier, but for some reason it didn't work. Let me see, it might be because of the way I had things structured. So we do that, then we do big skip. So let's see if I can do the function thing that I did earlier. And then do this, define document, and let's go ahead and do this, and see what happens here. Is defined but never used. That is wrong, but I guess it's because, oh, got it. It's not being passed in. So to pass in arguments, we have to do texp $. That's the same thing that we had to do before. So control that, texp $, and this passes it into the function. So now everything is good. We do hello document world. I just defined it, though. That's weird. Oh, got it. It's not in that package. I was in the wrong package. Oops. Moron. If we do hello document world, this will generate. Just do that. Our first successful tech document with a macro tech hello world. Now I'm going to go in and try and see if I can get this guy actually generating a proper DVI, which it should, but we've got to try this again. Obviously, there's going to be a lot more work behind this when you start doing more and more of the tech, because what you have to do, and this starts getting away from. This is one of the for some folks learning curve of learning tech itself, and why LaTeX was invented. There are certain style sheets that you need to define up front, like, how do you want to visualize, how do you want to align the text, how do you want to actually deal with the margins, what is the spacing in between individual particular pieces of text alongside in a document. Even it can, in some cases, and this is where Metafont will really step in, you can start defining, the M spacing between each individual piece of text inside of a document. So tech itself is a very versatile system in terms of what it provides. And this is why this here is basically just generating a series of macros that we're looking here. Ultimately, it allows you to, obviously use your standard, common Lisp. This library allows you to use the standard, common Lisp language and the idioms that we're kind of accustomed to actually generate fairly nice documents. So I'm going to go ahead and show you more of the document generation examples that we could use integrated with the common Lisp language. But I encourage you to recognize that this is not the complete thing. And the next step would obviously go in and take that tech and get it compiled into an appropriate document, which I don't think this library does. I think from what the documentation seems to say and what I've been reading, it looks like it doesn't actually compile a full document. But let me go and verify that one more time. Compile new line, compile parentheses, compile braces. So these guys are just nothing more than dealing with expressions, tech expressions, but they're not dealing with specific. Yeah, this is a pure tech compiler. What that means is it will generate tech and dump it to standard out or to whatever file if you associate, standard out with a different byte stream, but itself does not compile. You need to use the actual tech command in your local tech installation to actually go and compile the document. We could try that right now if folks are. I'm actually kind of curious. Let me go ahead and do that. Source. Just do example.tech. File, where is this? Yeah, okay. Let's go ahead and copy this guy. Okay. And let me see if I could fire up a shell here and compile this guy. Meta x shell. No, not right now. We'll do that later. Go to Osmo, fix, texp demo, source, and tech. This is new. This might be part of, I'm going to try tech.dvi. I don't know if this will work. Example.tech. Let's see. This is LaTeX. This is what I thought. Okay, so this is nothing more than PDF.tech. Let's see if I could use tech to DVI. No, I need pure tech. Compiling pure tech documents. There is a way of doing this. It's just I got to remember the options here. This was going to be in. Let's see if this works. This might work. PDF tech. Undefined control sequence. Why is it saying undefined control sequence? Let's see here. We need to specify this one was requiring this one input. So am I able to actually specify? Maybe there might be something that I missed here. Let's do this. Input AMS. Let's see if I have to do that. If I have to do that, then we're going to have to change a little bit of Define control sequence. Why is it saying that? Because I forgot to. This is, let's see. Let's see here. There's something. Okay. This is fixing up a tech document. I will do that in a later episode because clearly I'm not showing this library right now. I'm trying to fix tech. Let's go back to what we were doing before. Me and Lisp. Okay, so ignoring this compilation for a minute because of the fact that clearly there is some things about tech I have to go and remind myself in terms of compiling this guide. You can use this library to actually go ahead and, like I said, use standard common Lisp to go and generate your actual tech documents. Let's go ahead. Let's take an example straight from the documentation. That's this example that it defines kind of a little like menu or something like that. So this is interesting. Let me just read this a second here. Let me see if I could do this. Tech. I need to put in a by. Maybe, hold on. I think I found something here. Okay, we're going to try and work through this example here. We're going to go ahead and generate a function called it's going to be a little list. It's just going to be a list of items. Items list. You specify the items that you want. And then first what we're going to do is we're going to define what the item is going to be, and let's try that. So we do let's do this instead. We do let's see here. Let's see. Let's do this. We'll do items and prices. Okay. And this can be used for many things. Yeah. And this items is going to be items and prices. This is going to be just an associated list. Okay. So now what we'll do is we'll go ahead and create the simple text item that will take name and price. And we'll go ahead and, like I said, in order to add this into the code, you're going to have to actually escape it, and that's what the $ caption is doing. It actually grabs the item and then the argument, $name is doing. It's grabbing the item and then going in and trying to, it'll generate that into the actual tech code. It'll escape out of the tech environment, grab it from the Lisp environment, and stick it into the tech code. And then, of course, we need to go and do escape. Escape sequences are for providing essentially that backslash that I was showing you earlier. So here, this thing here can be written like this. Oops. Do this, and then take this guy out. Then what we do is we do Control Set, and we do texp escape. And if we do that, we will see that if we generate our document again, nothing's really changed. Oops, sorry, this is wrong. This needs to be I did that wrong. 1 second. This should be texp escape text bf. Then we could do this. We still need those braces. This will do what we wanted it to do. Yeah. Interesting. Why is that? Let's see. Does this do? Okay. So this is only needed for that other one. Okay. I take that back. We do need this for this backslash for the function calls, just because that escape character function call basically allows you to essentially provide the $ for like writing like numerical functions and stuff. Let me see something here. What does this do? Defined by, yeah. So it's specifically for things that are the escape is specifically for strings that are defined in the global escape table. So if we go and look into texp, I think we can just do this texp escape table. These are the characters that you need to you can essentially use, and it will do a lookup, and if it doesn't have one, it will just do /escape by default. Those are particularly necessary for some special types of formatting, like I said, for numerical symbols and things. So this here, since we're providing a price, needs to be escaped so that we can actually go ahead and provide the appropriate price. Let me go ahead and finish off this guy. And this is, oops. texp $price. So now we have our guy. Let's go ahead and do BR for break because we want a new line. And let's go ahead and use big skip. Skip is not there, huh? Now, if you're wondering about some of the stuff that I'm looking at here, these are internal symbols that I don't know if you'd want to jump in and start using, but they're somewhat useful for leveraging some built-in functionality for tech itself. And this library actually implements a lot of the Common Lisp library association stuff, so that you can use directly in your code. Let me do this, and let's go into here. Generate that. We have our Mac for, let's say, name and price in items and prices. And for folks who are not used to the loop language, I will colon it with keywords. And I actually prefer that we do that. Texp tech, and then we can just go ahead and call item. And then we have to, of course, use texp escape. I think it was texp. I'm not sure if this is going to work, but we will see if it will. Because I'm pretty sure that this is a reader macro. Because it looks like it's using named read tables, so texp $, and go ahead and do texp escape. texp escape. And let's go ahead and add one more thing, which is texp $, texp escape, do price. Okay, that's that. I am missing an extra parentheses somewhere. Let's see here. Oh, okay, looks like I'm not. All right. I was just being. That's why I deleted one of those. Okay, texp br. Okay. All right. Let's see what happens. One error condition. What is that error condition? Cannot find in the texp package. Let me see if I could just do this. That worked. Interesting. Let's see now if we can, if this actually generates what we want. Items list. Computer 1500. Monitor 99. Mouse. A good mouse is probably like $20. Alright, let's see what happens. What do we do when we do this? Very nice. I've only got, oh, yes, that's right. This is why I need to pay more attention to that. And controls. Now this will work. Now this isn't completely optimized, but this gives you an idea on what actually, you know what? I think that's because it looped it out. Give me a second. Oops, sorry. It would be in better. Boom. So, as you can see here, what we've done is we've defined another macro. We've went ahead and defined a list, and then we printed this guy out. This, according to the documentation, should actually, like before, work with what we did before with our Hello World program. But like I said, my looks like they're providing something. They're using a different tech package than I'm using, so I might have to do some. Let's see here. Let me see why I'm getting that. Tech undefined control sequence. Let me just look at one thing here. Let's save this. I see what the problem is. This is it's related to this. So the problem that we're seeing here, so if we use this guy here, I figured out why this earlier wasn't working. So this is because of the fact that we're having /tech hello world here. So what we need to do is we need to do this. Hello $p name. And that will fix that. Clear REPL. Do this. Compile that. Nice. This is what I needed. Okay. And let's see if I could get this generated into okay. We could run tech example.tech and oh, got it. I cannot use this guy either because this is not defined. This is LaTeX, not tech. A lot of stuff that we have to remember about LaTeX and tech. Tech requires more packages that you need to take care of. So let me get rid of that and do that. Shift this. Okay, this guy. Okay, and if I do shell, boom. So just to give you what the compilation process does for folks who are going in and looking at this, tech alone allows you to specify lists of documents that you want to actually go and generate, all right? And it will all load them up. But you have to explicitly, and you could see this here, you can say /end, and it will then, at that point, sorry, I keep forgetting I'm in Emacs. So when you hit end, at that point, it will actually generate the final DVI. And you can see here, example.dvi is there. You can also use example PDF tech directly, and that should generate the same thing. And if you do end, it will generate your PDF. Now, I don't remember if there's a way to open up the PDF in Doom Emacs. I know Emacs has a way of actually viewing the PDF. Anyone in the Hangouts know how to open up the PDF in Emacs? No? Alright, let me go on. Let's see if they're opening PDF in Emacs. Ah, very nice. Like normal files. Okay, so let's see if this works. F example.pdf, and you see that we have a document, hello world, in the upper right hand corner. Of course, that doesn't yeah, it looks like so someone commented that you could, if you had PDF tools installed, you could just use Control X, Control F. Yeah, that's right. I had to look this up just to make sure. I think PDF tools is now installed by default, unless you explicitly uninstalled it since Emacs 23. So I'm running. But thank you for that comment. Are there any questions on either the live stream or the any other questions on the live stream? Let me go look at the live stream here for a second. Okay. Yes. Okay. Yeah. Excellent. Excellent question. Can we see an example with the list of items? Yes. We could certainly do so. Give me a second. Let me go back into here and see if I could just close that, and then let's actually add. Yeah. Let's do that. We will generate the list of items. Then yank it, put it into our existing file here. Go into the shell, find PDF tech. Hopefully it's there. And when we open up our PDF, you can see that we now have a list of items. So one of the nice things about this library that that actually attracted me to it is just the fact that this is. Can you see the PDF, folks that are on the stream? I'm just making sure that. You can also generate a DVI, but I'm using PDF just for convenience because there's no built-in DVI viewer in Emacs. You can also use, just to let you know, the tech tools that come, like whether you're using MacTech or TTech or Tech Live or Tech Shop or any of the tech tools out there, they give you multiple formats. Just to illustrate this, PS Tech is available. Sorry, I used the wrong thing. PS Tech is another thing that's available. I think by default, PS Tech has been. I don't know if actually it doesn't look like it's available. It used to be available. There used to be a version of Tech that allows you to compile to PostScript. It will compile to PDF. It will compile to DVI. Like I said, that's the default format for it. So this gives you some flexibility is kind of what I'm trying to get at. You can certainly, and this is something that I'm going to close up this today's session in, is you could change, if I'm not mistaken, the standard out here so that we can actually execute this guy in and write it to a file. So if I do, what was the correct thing to do here? It was, I think, if I get the file stream, yeah, I think I could just do this. With open file, file stream, let's do this, call this tilde Roswell projects. I'm just going to go ahead and write this all into the tech demo, texp demo, source texp demo.tech. Okay, and it's not direction, is output, input. Okay, so now what I'll do is let me go ahead and slurp this document and go ahead and wrap this guy around and just change standard output to being our file stream. Compile this guy. So now if we go and open up texp demo, you'll see that we have our item list. So now you don't, if you guys want to like write your full tech document and just write it out to a file, just go ahead and write a function here like that will take in a file output and then call write to file. Because I didn't see this in the documentation, but this is pretty easy to write. That will then, just do what I just did here, which is redirect standard output to a file stream and dump it, the stuff to a file that you could then go ahead and compile. So this is a brief overview of this library. Like I said, I haven't had a chance to really play around with it to figure out how to write style sheets, because that's a big thing about tech. When you start writing more and more of your tech, you'll end up recognizing certain patterns that you may want to adopt in multiple documents, in which case you may want to just go ahead and preserve those and just load them into your tech document. Those things are called style sheets, and there are a lot of them out there. For example, if you're trying to publish a paper to a technical journal like either AMS Math or even the journals for like the ACM or something, you can certainly find a particular style sheet that matches that and then include that into your tech document. texp gives you the possibility to do some of that. Again, I have to go and hunt some of that down just because I think some of it is internalized into the library because it doesn't want you to necessarily play around with those things. But that said, if there are things that need to be exposed, and it turns out that it's an internal definition, you may want to just go ahead and submit like a request on the project page to actually go in and update it so that certain definitions get exposed into the library. That's all I have today. Like I said, in our coming weeks, we're going to have a few more functional programming talks that are not Lisp. Next, Common Lisp Study Group. I'm hoping to go over the second part of the series library, which is a paper that talks about its particular implementation details, and hopefully uh, we can try and see if we can reconstruct a primitive but functioning version of this library. That's currently what I'm actually reading through right now. This paper is already available for folks who are actually looking at it in the series talk that we gave about a year ago. I will go ahead and review the series library for folks who aren't there at that in next time, just so that we're all on the same page, and that way we can actually go ahead and start doing some real functional programming and getting a functional programming library up and running. So that's it for me. I appreciate all of you joining me today, and I will see you guys next week.